Okay, now that we have set up the model, we're going to now use solver to find the least possible project duration that can be achieved at the least possible project cost. So solver is available under the tab data right here. Now for some of you, you may not see solver here, in which case you have to activate it. So go to File, Options, and Add-ins, and here Excel add-ins, click Go, and you will see solver add-in here, and if it is unchecked, put a check here. Once you put a check there, the solver will appear. So what we're going to do now, before we get into solver, let's examine what we're going to do. So we want to minimize the project duration, and we want to minimize the total project cost for that duration. So you have to do this in two steps. In the first step, we will find what the least possible duration is, and then holding the project at that least possible duration will minimize the total project cost. So it's a two-step process. Okay, go to solver. Okay, now you see a blank solver. So remember, there are two steps. In step one, we want to find the least possible project duration. So our first objective is that cell, the project duration cell, and we want to minimize that. And we want to do that by experimenting different values for weeks crashed, and that's why those are the changing variable cells. Solver will try many different values here. But there is a constraint too. You cannot crash by any amount. So the amount of crashing that we can do is limited by MCA, maximum crashing allowed, and we're going to include that as a constraint. So add weeks crashed should be less than or equal to MCA. Okay. Now make unconstrained variables non-negative. Okay, so GRG non-linear. You may want to add one more constraint if some of these weeks crashed happen to be non-integer and you want them to be integer, then you can add another constraint which says weeks crashed. Okay, here from the middle you select INT. INT stands for integer. Okay, now click solve. Now you need to make sure that you have make sure that solver found a solution for you. Now since we are using non-linear program, it is possible sometimes you may get only a local optimum and not a global optimum. Okay, so you want to try different starting values. Okay, for the first time we had completely blank, in other words 0 crashing. But now you may want to try, okay, arbitrarily you can select any value you want and see whether by running the solver again you get the same 12. Okay, we got 12 again, so maybe 12 is the answer. Well, let's just try one more, and let's really put some crazy numbers here and then see whether we still get 12, in which case 12 is most likely the best possible answer. So that's right, that's 12 is what I got. Okay, so that's the first step. Okay, we know that 12 is the least possible project duration. Now we need to now keep the project duration at 12 and minimize the project cost so that we will achieve the 12 with the least possible cost. So we have to go back here to solver. Okay, so now instead of minimizing project duration, we're going to have to minimize the total project cost. Still minimize. Now at this stage we have to make sure that the project duration remains at 12. So we have to add that as a constraint. So you add that equal to or less than or equal to 12. Add that constraint. So now if you solve, this will be fixed at 12, and Excel solver will try different combination of weeks crash to try to minimize the project cost, which is right now 15,900. Solve. Okay, so now you get same 12 for 14,100. Okay, remember we have to now try different combination of values to see whether we still get 14,100. So I'm going to try some crazy numbers here. Solve again. And try one more. It turns out that 14,100 is the least possible cost. Now I have screenshot for Excel 2007 solver, and this is 2010 solver. So there was a change in the dialog screen between 2007 and 2010. I've given you both 2007 and 10 here, and on the side, if solver is not visible, then how to make solver visible. Instructions are here on the right side.